Hi everybody, this video is going to deal with SigFigs and calculations. It's important to know how many significant figures we need to report when we do a calculation, depending on addition, subtraction, division, or multiplication. First, we're going to deal with addition and subtraction. In addition and subtraction, the answer has to go to the smallest decimal place. Make sure that you understand the difference between the smallest decimal place and the smallest significant figure. Here, I'm showing you a number. It's 0.073 plus 10.00377. What I like to do is I like to line these numbers up basically so I can see exactly where the decimal point is, and then I look to see which number has the smallest number of decimal places. It obviously is this one, and if you just in your mind go ahead and put an arrow down, that's the last spot that you can have your answer to. If you put it in your calculator, if you put 0.073 plus 10.00377, you're going to get that entire number. It's going to be 10.07677, but according to SigFig rules, you can't report all of that number. You can only report it to the least number of decimal places, which happens to be this number right here. So you would have to round. And if we round it, it would be equal to 10.077. The reasoning behind this is because think about what you're doing. You have a number that is only 3 decimal places in accuracy, and then you have another, you're adding it to another number that has 5 decimal places of accuracy. In essence, what you're saying is, how can you report a number with more accuracy if one of the numbers that you're using to get to the final answer has less accuracy than your answer? Does that make sense? If this number has 5 decimal places, but the numbers that you used to actually get this answer only had 3 decimal places, how can your answer have more accuracy than what you used to get that number? It doesn't make sense. So you have to keep it to the smallest decimal place so that the answer could be correct in significant figures. In multiplication and division, it's a little bit easier. The answer has to go to the smallest number of significant figures. Last week, we learned how to determine how many SigFigs a number has. And now when we multiply numbers or divide numbers together, we basically look at both of the numbers and we say, okay, which one has the smallest number of SigFigs? And we report our answer to that number of SigFigs. So for example, if I have a number like 85. 85 has how many significant figures? It's got 2 significant figures. And then I'm multiplying it times this number here, which is 0.004. This number only has 1 significant figure. That 4 right there is the only number that's significant, because remember, the zeros before the first non-zero digit never count. So you're basically multiplying a number with 2 SigFigs times a number with 1 SigFig. So your answer, if you were to put it into your calculator, you would get 0.34. But you have to be smart enough now to know that you cannot report this answer with 2 SigFigs. You have to only report it with 1 SigFig, because the rule is when you multiply and divide, the answer goes to the smallest number of significant figures. Therefore, you have to report it as 0.3. The answer would only have 1 significant figure. Okay, so the last piece of information you need is for SigFigs and calculations is exact conversions have an infinite number of significant figures. This little symbol here means infinite. So what does that mean? We're going to be doing conversions. We're going to be using the factor label method very soon to convert units to other units. And most of the time we're going to be using these exact conversions. And what I mean by that is 1,000 milliliters is exactly 1 liter. These are not measured values. These are exact definitions. And when you use these exact definitions in a calculation, you don't take into account into your SigFig calculation. Because if you did, that means that every time that you would use this conversion right here, this 1,000 milliliters is equal to 1 liter, that means that if you followed the rules, your answer would always have one significant figure because of this one right here. And that just wouldn't make sense. So the rule is that when you're using exact conversions, you don't use them when you're trying to calculate how many SigFigs you should report in an answer. This might not make too much sense to you right now, but you'll see when we start doing dimensional analysis or when we start converting units to other units and we use these exact conversions, you'll see that this will make sense to you. Another example I can give you is, for example, let's say I have something that I've weighed out and it weighs 13.7 grams and I'm multiplying it times 9. 9 is not a number that I've measured. 9 is an exact number, something that, okay, well, I measured 13.7, that I weighed it on a balance, but I'm going to go ahead and just multiply that, what I weighed, times 9. And that 9 would be considered an exact conversion. So when I go to report my answer, I have to only take into account this number right here, which has 3 SigFigs. That's why my answer should be 3 SigFigs. It should not be 1 SigFig because I didn't measure this. So in other words, when you do calculations, you only take into account measured values when you're trying to calculate your significant figures. Okay, now I want to talk about rounding numbers. It's very important that you know how to properly round off numbers. A lot of you know the basic rules, but some of you might not know the last 2 rules that we're going to talk about. So the first rule is if the figure to be dropped is less than 5, simply eliminate it. This is easy. Let's say I have a number like 7.0234, and I tell you that I want to round off this number to 4 significant figures. Well, you would tell me, okay, it's 7.023. I only want the number to be 4 SigFigs, so I just go ahead and drop off that 4 because it's less than 5, and the number stays as 7.023. Pretty easy. Number 2, if the figure to be dropped is greater than 5, then you eliminate it and raise the preceding figure by 1. That's pretty simple too. I'm sure you've seen this. So let's say my number is 7.0236. And I want you to round it off to 4 SigFigs. Well, I see that the 4th SigFig is that 3, but the 6 is right after it. So I have to raise the 3 to a 4 because that 6 is higher than 5. So my final answer would be 7.024. Number 3, if the figure is 5, followed by non-zero digits, raise the preceding figure by 1. Non-zero digits means obviously any digit that isn't 0, right? So let's say, for example, I have 7.02351. And again, I want to round it off to 4 SigFigs. That 4th significant figure is that 3. That 3 is followed by a 5. But that 5 is still followed by non-zero digits. So I would basically raise the preceding figure, and the preceding figure means the figure before the 5. I would raise it by 1. So my final answer would be 7.024. Because again, I wanted to round it off to 4 SigFigs, and the number after the 4th SigFig is a 5, but the 5 has numbers after it, so I got to raise that 3 up to a 4. Okay, number 4 you probably have never heard of before. If the figure is 5 and it's not followed by non-zero digits, so basically it means that it has nothing after the 5. If the figure is 5 and it's not followed by non-zero digits and it's preceded by an odd digit, then raise the preceding digit by 1. Okay, so let's say my number is 7.0235. There's nothing after the 5. Right? So that's what it says there, not followed by non-zero digits. And then the preceded digit is odd. So the number that's before the 5 is odd. Then I have to raise that 4th digit, the one that I'm trying to round, up making my answer 7.024. Again, if the figure is 5 and it's not followed by any digits, so I've got 7.0235, that 5 isn't followed by anybody, and then that 5 is preceded by an odd number, then I have to raise that number up by 1 if I want it to round off to the 4th digit. Okay, so the number 5 is the opposite of that. If the figure is 5 and it's not followed by non-zero digits, and now the preceding digit is even, then that preceding digit remains unchanged. Let's say now my number is 7.0245, and I want to round it off to 4 significant figures. Well, that 4th significant figure is that 4. What's following the 4? It's a 5. Is there anything after that 5? No. So now, since there's nothing after that 5, I have to look to the number before the 5. Since the number before the 5 is even, that number stays the same. So my final answer, again, would be 7.024. I hope that doesn't confuse you guys too much. Let's try some examples to make sure that we understand. So let's round these numbers to 3 significant figures. A, 3.478. Well, if I want to round it to 3 significant figures, that's really easy. It would be 3.48. The 7th is the 3rd significant figure, and I need to raise that up because there's an 8 after it. How about the second one, 5.333? Well, that's really easy as well. That would be 5.33. What about the third one, 4.8055? Well, the 3rd significant digit there is that 0. So I have to look after the 0. After the 0, I have a 5. And after that 5, there's still another number. So that means that I would have to raise that 0 up to 1, 4.81. That's actually explained in rule number 3. All right, what about the last one? 7.999 inches, and I want to round it off to 3 significant figures. Well, the 3rd significant digit would be this 9 right here. So I have to basically round up. But if I round this number up, then this number also gets rounded up because it's a 7.9. So actually what ends up happening is I have to round all of these up to 8.00. And remember, 8.00 does have 3 significant figures because zeros after count if you see a decimal point. All right, I hope this video was helpful to you. Please make sure that you practice and keep practicing how to deal with significant figures in calculations and how to properly round off numbers. I'm going to do a couple more videos that deal with unit conversions and factor label method, and try to help you learn how to manipulate algebraic equations. All right, guys, see you later.